Alrighty, remember for these angle formulas, there is, like I said, a formula for that. So here are your half angle formulas. Okay, notice that the sine of the half of some angle, this, whatever your angle is, right, whatever your theta is, it's really important to understand that whatever you have here is what we're finding the trig value for on the inside. Okay, so we're going to get to that in our second example today. But your angle, whatever is in your numerator as a fraction, right, your numerator of your fraction is what we're going to be taking the trig of. Okay, that's important to understand. So the positive and negative, depending on what quadrant we're in, sine is going to be positive or negative. Cosine is going to be positive or negative. Okay, right, the second and first quadrant signs are positive, so it's important to understand the SIGN, the sign of your sine and cosine. And it all comes from our quadrants. But first and foremost, we need to figure out what our missing side of our triangle is. And to do that, we always use our dead friend Pythagoras. 13 squared equals 5 squared plus. Well, this is the horizontal side, so I'm going to call it x squared. Okay, and when you do this Pythagorean, we get an x value of 12, right? Because this is a Pythagorean triple, 5, 12, 13 as the hypotenuse. That's a pretty standard one that we should know about today. All right, so now let's get to working in our formulas. Okay, so we're going to assume that unless we are given a quadrant that we have a positive square root, right? We have a positive value for our sine and our cosine. Half of this angle, right? Half. So we're going to chop the angle in half and then figure out what the sine and cosine are going to be. Okay, so our formula for sine is 1 minus the cosine of the angle divided by 2. So now it is our job to figure out what the cosine ratio is from our triangle. Okay, what is the cosine ratio from our triangle? And the answer is 12 over 13. So right here where the cosine was, I am going to instead put that ratio of 12 over 13. Okay, and I have the luxury of an eraser. Maybe you have an eraser too, and can just erase cosine and put 12 over 13 in there. Okay. Also, I have the luxury of an eraser because now I need to change my 1. Right? If I'm going to subtract something minus a fraction, I have to create another fraction. So I'm going to change my 1 into 13 over 13. Okay, so I always change my 1 so that it matches up with my denominator. I have a denominator of 13, so my other denominator needs to be 13. Okay, so now all of that stuff is done, right? We've done all of our switcho, presto, changeo stuff. Now we can actually get to simplifying. Okay, square root. Leave the square root where it is. 13 over 13 minus 12 over 13 is 1 over 13. And we're dividing that by 2. 1/13 divided by 2. So we're staying underneath our radical, and we're going to change our division of 2 to multiplying by 1 over 2, right? Multiplying by 1/2. Dividing by 2 is the same as multiplying by 1/2. So this becomes the square root of 1 over 26. Not looking any simpler, is it? Well, we can do something else algebraically, right? If that's not an option for you, we can split this into the square root of the top over the square root of the bottom, right? That is mathematically legal to do, right? And we're all doing this in the name of simplifying, right? So we're trying to make it more simple. Oftentimes, making it more simple requires some pretty complicated stuff. So this becomes positive 1, because that's what the square root of 1 is, over root 26. And then we're going to rationalize, and our final answer is going to be root 26 over normal 26. Okay, if you have a radical in the denominator, it goes to the top, and the bottom becomes no longer a radical. All right, pretty snazzy. The cosine, right? Half of this angle for the cosine, the formula says, is the square root of 1 plus the cosine of the angle divided by 2, right? This is the formula. So once again, I'm going to replace cosine with 12 over 13, right? That hasn't changed. 12 over 13 is still your cosine fraction. Okay, I'm going to replace my 1 with 13 over 13 again. And now I'm going to add in my numerator. I'm going to add. So 13 plus 12 is 25 over 13, all divided by 2. Okay, so we do the same procedures, right? We're going to have to multiply by the reciprocal underneath our radical. We have 25 over 13 times 1 over 2. Right? Dividing by 2 is the same as multiplying by 1/2. So I get the square root of 25 over 26. Okay? This one's looking kind of promising. Let's split this into the square root of the top and the bottom. Root 25 over root 26. Okay, split it into the root of the top and the bottom. Well, in this case, what's the square root of 25? The whole number 5. And then I have root 26 on the bottom still. Okay, but we don't leave it like that. We rationalize. So 5 roots of 26 divided by 26. Okay, so that might be the stuff that we really need to practice again, is this rationalizing of radical business. Okay? Mathematicians don't like to leave radicals in denominators, so we do a process called rationalizing. Remember, a radical is an irrational number. It is a non-repeating decimal. So to make something irrational, we call it rationalizing, right? We make it a rational thing. But that's just nomenclature. Anyway, let's move on. Tangent. So there are 3 options for tangent. Which one do you want to use? The one with the radical or the ones that don't have radicals? Okay. This one tends to be my favorite to use just because it doesn't have a plus in the denominator, right? It has a plus in the numerator, which I'm just more mathematically comfortable with having a minus. Not having an operation in the numerator if I can potentially avoid it. And in this case, I can. So 1 minus cosine over the sine. Okay, so we're going to replace cosine. That was the same as it's always been, 12 over 13. Okay, now we look at the sine. What is the sine of our angle? The opposite over the hypotenuse. 5 over 13. Okay, so my sine value is 5/13. My cosine is 12/13. I change my 1, right? My fancy 1 becomes 13 over 13. Beautiful, all these things. And now let's do our subtraction. 13 minus 12 is 1 over 13 divided by 5 over 13. And hopefully we know that when we have the same denominator, right, 13 denominator on top and divided by 13 on bottom, those ones will multiply each other out when we actually do the reciprocal. And we get an answer of 1/5. 1/5. Okay? So notice that's the coefficient of your y thing here, right? This is 1 root 26 over 26. And this is the coefficient, right, of your 1 there, right? So these numbers, just like they did with the double angle, with the half angle, these ones kind of have the same shortcuts, okay? But it's a lot less obvious here than it was with those double angle formulas for the other day. Okay, so that's some practice with the formulas. Now let's get into how we actually use this. So the angle we want to find is the tangent at 105 degrees. So you need to think to yourself, 105 is half of what angle? 105 is half of what angle? So in other words, just multiply it by 2. If we do 105 times 2, we get 210. Okay? Because I want my half angle to look like my formula. Right? I want it to look like the formula, theta over 2 is my half angle. 105 is half of 210. Okay, so when I use my formula, this becomes 1 minus the cosine of 210 divided by the sine of 210. Remember I said at the beginning, whatever your theta is, so this is theta over 2, that's the angle that we use in our calculation. Okay, so you multiply 105 by 2 in order to find out what angle we're going to use to get the trig from. Now let's think about this for a second. Tangent is 105. This is in the second quadrant. Okay, 105 degrees is between 90 and 180. So we should be expecting our answer to be negative because the tangent is negative in the second quadrant. Okay, so let's see if that actually comes true. Okay, let's go to our unit circle. The cosine of 210 degrees. Oh man, this is in the third quadrant. 210 degrees is also known as 7 pi over 6, I believe, if you are a radian person. Anyway, the cosine at 210 degrees is negative root 3 over 2. Okay, that's the cosine at 210 degrees. And the sine at 210 degrees is negative 1/2. So now let's get to simplifying. Minus a minus is a plus. Okay, I'm going to replace my 1 with 2 over 2. Okay, because my denominator right here is a 2, so I have to add it together with another denominator of 2. Now I can add, so my numerator says, what is 2 plus root 3? Well, that's just 2 plus root 3, right? There's nothing to combine when we're adding a number and a radical, so they just sit next to each other with a plus sign in between them, right? There's nothing to quote-unquote combine. Divided by negative 1/2. Okay, so we're running into the same situation where these both have denominators of 2, which means they divide each other out. But what's left in my numerator? A negative 1. So what's 2 plus root 3 divided by negative 1? Negative 2 minus root 3. Negative 2 minus root 3, which is, of course, a negative number. So my suspicion at the beginning that my tan of 105 would be negative is, in fact, coming true. So I'm okay with this answer. It's a negative. It looks very strange, I understand, but it's the right answer. Let's see what's next. The sine at 112.5. So once again, 112.5 is half of what number? So if we times it by 2, 112.5 is 225. Okay? Remember, we want it to be in a half angle formula style, meaning we have an angle divided by 2. So the sine at 112.5 is 225 divided by 2. Now, once again, 112 is a second quadrant angle, but it's a sine, So we're going to have positive as our value outside of your square root. Okay? And of course, if it's a positive, that means that we don't have to write plus. But if it's a negative, if this angle is in the third or the fourth quadrant, you need to make sure to write a negative in front of your square root. But because it's a second quadrant and it's a sine, then we have a positive thing going on. Okay, so our formula was 1 minus the cosine at, in this case, 225. Okay, because whatever we have here, that's what we are taking the cosine of inside of our formula. So 225, 1 minus the cosine of 225. Okay, 225 is also known as 5 pi over 4. The cosine at 5 pi over 4 is negative root 2 over 2. Negative root 2 over 2. That's the cosine at 225. Okay, that comes from your unit circle. In the third quadrant is where 225 lives, so cosine is negative. Okay, now we're going to change your 1 to be 2 over 2, right? Because you always want to make sure your denominators are the same. The denominator of this guy, right? Not your denominator of the whole thing, but the denominator in your numerator, right? So there's a lot of things we need to keep track of. Minus a minus is a plus. Minus a minus is a plus. So let's add these together. I can add my numerators, right, and get 2 plus root 2 divided by 2, right? That's my numerator, all divided by 2. Okay, so this divided by 2 is still there, that divided by 2. Okay, so don't forget about the formulas. Okay, now we're going to multiply by its reciprocal. Okay, so we have the numerator, which is this crazy looking thing, times the reciprocal of 2 is 1/2. The reciprocal of 2 is 1/2. That's the reciprocal of this. So 2 divided by 1 is a multiplier of 1/2. Okay, so our next step is to multiply in your denominator, right? Because multiplying this by 1 doesn't change anything. So 2 plus root 2 on top, and 2 times 2 on the bottom becomes a 4. Okay, our next step is that we're running out of room. We can split the square root of the top and the bottom. So I have the root of, right, something crazy. We don't ever see this before, not to the best of my knowledge. The root of 2 plus root 2 divided by root 4. Okay, what can we simplify here? The root 4. What is the square root of 4? By Jove, it's the number 2. So our final answer, as crazy as it might look, is the square root of 2 plus the square root of 2, all divided by 2. Okay, this is what your sine and your cosines are going to look like for these half angle problems. Okay, pretty snazzy looking things that we haven't ever dealt with before. So remember, there's a formula, and we want to replace your cosine and your sine with their unit circle angles if we're using unit circles. If not, we're using triangle ratios to replace our things. Okay, have some fun with these half angle formulas.